Can a bridge actually wave in the wind like a piece of jelly before completely collapsing? In 1940, the Tacoma Narrows Bridge did exactly that. Just 4 months after opening, mild winds caused the entire solid steel and concrete structure to twist violently. Civil engineers at the time didn't account for aerodynamics. The solid side girders acted like giant airplane wings. This created a destructive cycle called aerodynamic flutter. Because of this costly mistake, every modern bridge today is designed with open air vents.
If you've ever seen a construction site, you've probably noticed workers pouring water all over perfectly good concrete. It looks like they're ruining it, but drying out is actually the absolute worst thing that can happen to fresh concrete. Here is the civil engineering secret: concrete doesn't harden by drying. It hardens through a chemical reaction called hydration. When cement mixes with water, it creates microscopic crystals that lock together like steel chains. If the water evaporates too fast under the hot sun, that reaction stops cold. The result? Weak, chalky concrete that will crack under pressure. Keeping it wet, or curing it, makes it up to 50% stronger.
Why is 2,000-year-old Roman concrete stronger than modern mixes? Modern concrete structures can degrade in decades. Roman harbors withstand seawater for millennia. For centuries, engineers wondered why. The secret is a mixing technique using volcanic ash and lime. When a crack forms, rainwater seeps in, dissolving lime and recrystallizing it, healing itself.
This simple concrete mistake can bring down a 50-story skyscraper. When workers mix concrete on a busy site, it's tempting to add a little extra water to make it easier and faster to pour. But in civil engineering, that extra water is a death sentence for the structure. Here's why. When that extra water eventually evaporates, it leaves behind millions of microscopic holes inside the pillars. It turns solid rock into a giant, heavy sponge. The concrete loses up to 30% of its strength, leading to catastrophic cracks. Hit subscribe to the Civil Engineer's Corner to see how we keep structures standing. This simple